Okay, so welcome to today's deep dive. Our mission today is actually exploring a really specific piece of tech hardware. But first, have you ever, walked into a massive sports bar and just looked at the walls?
Oh, yeah, there's always, 50 pristine monitors mounted everywhere.
Right, exactly. 50 monitors, perfectly synced up. But you never see a bulky PC tower anywhere near them,
Right, no, definitely not.
or even a tangle of thick wires. So how are they getting high-def video to all those screens without the signal just, completely dying over that distance?
Well, that is where the invisible infrastructure comes in. You're really looking at the magic of industrial-grade AV extenders. And specifically today, we're looking at the technical specs and storefront data for a real heavy hitter in this space. It's the Smart-AVI SDX-XT-TX-S extender transmitter, and we're pulling this from HDTVSupply.
Right, because, I mean, anyone who's ever tried to set up a home theater knows that standard HDMI or DVI cables, they top out at what, maybe 50 feet?
Yeah, if you're lucky, usually the signal drops way before that.
Exactly. But this specific Smart AVI unit, it's actually pushing DVI-D video, so that's a full 1920 by 1200 resolution plus USB 2.0 controls and stereo audio. And it's doing all of that up to 500 feet away.
Which is honestly wild.
Right. And the craziest part is it's doing it over just a standard, cheap CT5 5E or 6 network cable.
Yeah, and that's incredibly efficient because it doesn't rely on those, proprietary, ultra-expensive fiber optic lines to bridge the gap.
But okay, here's the part I really need help understanding. A standard CT5 cable just isn't built for high bandwidth video. I mean, it really feels like trying to push a fire hose of data through a garden hose. How is this transmitter forcing uncompressed video through that wire?
It's a great question, actually, because physically it seems impossible to maintain that signal integrity over 500 feet. But the secret here isn't compression. It's how the data is encoded on the wire.
Wait, so it's not compressing the video at all?
Not at all. So standard video cables use a lot of separate wires to send parallel signals, right? The Smart-AVI device takes that massive video signal and translates it into something called differential signaling.
Differential signaling, what does that actually mean?
Well, it's designed specifically to leverage the twisted pairs inside a CT5 cable. Basically, it sends the exact same signal down two parallel wires, but one of those signals is inverted.
Ah, okay, so they're like mirror images of each other.
Exactly. And when it reaches the receiver 500 feet away, the device compares the two. Now, any electrical noise or interference that got picked up along that long journey is going to affect both wires equally.
Right, because they're right next to each other.
Yes. So the receiver then mathematically subtracts the noise, and that leaves you with only the pure original video signal.
Oh, wow. That is brilliant. And I guess that explains why the specs say there is less than 1 millisecond of latency.
Spot on. Since it's not stopping to, compress and decompress the data into IP packets, there's no delay.
It's just raw data surfing those twisted pairs. So you could be using a mouse and keyboard 500 feet away from the computer, and you wouldn't even feel a lag.
Yeah, you get a completely flawless real-time experience.
Okay, but I do have to play devil's advocate here for a second. I'm looking at the price tag, and this tiny, 1 pound box is almost $700.
Yeah, it's about $679.
Right. So why spend nearly $700 on this instead of just, buying a cheap small form factor computer and mounting it directly behind the TV?
Yeah.
I mean, that would avoid the long cabling entirely.
Well, you have to look at the larger context. If you check out the other categories on this storefront, you'll see things like sports bar TV systems or TAA-compliant government purchasing.
Oh, TAA compliant, meaning it's manufactured in the U.S. or an approved country,
Yeah.
right?
Yes, which is a strict legal requirement for secure federal contracts. So think about a highly secure government facility or even just a messy restaurant where drinks are constantly getting spilled. Putting an actual computer right behind a screen in those environments is a massive security risk, not to mention a total maintenance nightmare.
Ah, that makes a lot of sense. So you really want the expensive brains of the operation locked safely away in a secure, climate-controlled server room.
Precisely. You leave only this little 7.8-inch metal transmitter near the actual display, and it's built to be completely foolproof for the IT teams who manage the building. Like, it features automatic DDC learning.
DDC being displayed data channel.
Right. It's essentially a digital handshake. So the transmitter pings the monitor, asks what resolution it prefers, and instantly adjusts the video output to match.
Wow, so no drivers to install?
None. No software to troubleshoot at all. It just works right out of the box across Windows, Mac, or Linux. It really is a plug-and-play lifesaver.
Learning about this really changes how you look at public spaces. I think the next time you are at the airport or a sports bar and you're looking at a standalone display mounted seamlessly to a pillar, you'll actually know about the invisible infrastructure hiding right behind the drywall.
Yeah, you'll know there's likely a cheap network cable carrying a full multimedia workstation from hundreds of feet away.
Exactly, just using differential signaling to push all that data right to the screen.
It's amazing. And this raises an important question for you to mull over. If we can already manipulate electrical signals to push uncompressed high-def video and USB control 500 feet over a simple traditional network cable today, what happens to AV design when physical cables eventually become entirely obsolete? Like, imagine when we figure out how to transmit this kind of zero latency, uncompressed data entirely wirelessly.